All right, hello and welcome to today's webinar, Dynamics 365 for Connected Field Service, What It Is and the Benefits for All, brought to you by MCA Connect. Today's presenter is Travis Pullen. Travis is a pre-sales director at MCA Connect and leads our Dynamics 365 for Field Service and Connected Field Service practice. He came to MCA Connect with over 6 years of technical experience with Dynamics 365 at Microsoft and is recognized as a thought leader in the field service and customer engagement fields. So with that, I'll go ahead and hand the stage off to Travis for the presentation.
Great. Thank you, Kelsey. So let's talk a little bit about connected field service. I'm sure if you're in the industry, you've heard a lot about connected field service, and unfortunately, a lot of what you've probably heard is that in order to be successful in delivering a never-fail, proactive or predictive service to your customers, you have to have all your devices connected to the internet. They all have to be IoT enabled. They all have to be smart. When in fact, we believe that that is not the case. We believe that to be a myth. Never fail service is absolutely possible without smart devices. And why we say that is, the reason you never fail is really all about prediction, and prediction is all about data. We can use devices to accelerate the collection of data and to improve the accuracy of that data collection, but it does not prevent us from getting to that prediction state just by collecting data on our own more manually. Many manufacturing companies have been collecting data for decades, and they have a lot of this data already and are able to come up with the predictions for useful life of a component without leveraging IoT devices. So in this presentation, we're going to walk through how to get to that predictive or proactive state. We're going to talk about, what does that proactive service look like with smart devices and without, and what are some of the common obstacles to deploying these devices. If IoT devices, if smart devices are this holy grail, why isn't everybody doing it, right? What are some of the things that are stopping people from achieving those results? All right, so proactive service and smart devices, they are not necessarily tied or coupled to each other. Proactive and predictive service is really just a matter of collecting. You have to collect tons and tons of data, right? And taking that data and correlating failures with point in time data from your devices. So in other words, when you get a failure, you take the date and time, subtract it from the date and time that it was installed, and that comes up with your duration of time. And your point of time is really your collection of those point in time correlations is what's going to prove or give you that accurate useful life prediction. So that's what that second point here is the intersection point of failure and time provides us with that accurate prediction of useful life. And the benefit to knowing what the useful life is, obviously, you can then set up a preventative maintenance program to go and replace those components that are about to expire or about to fail based on our predictions, and get to kind of that never fail sort of environment. The bonus here is that having that accurate useful life data allows you to do your asset depreciation charts a little bit more accurately. So your finance people are going to like that. All right, moving on. So why isn't everybody doing it, right? What are some of the obstacles to deploying IoT devices out into the field? I've kind of divided it up into two main areas, right? One is location. We deal with a lot of manufacturing companies, a lot of oil and gas companies, and their plants or their pads or their well sites, they are highly distributed, and some of them are in the middle of nowhere and far, far apart from power or cell phone connectivity. Certainly not wireless kind of planted phone lines or anything like that. Not a lot of infrastructure. Challenges with you don't own the property, so how do you get in? If it's a building, do you have access to it? If it's a well site, can you get in the gate? Obviously distances, physical locations. Is it at the top of a building? Do you need to climb to it? Is it at the bottom of the ocean? Do you need a submarine to get to it? Right? There are a lot of extremes here, but it is an obstacle for some of our customers. Then of course extreme conditions. We talked about oil and gas. Midland, Texas. If you've ever been there, it's not a very hospitable place. So very, very hot, very, very dry. If you're out on the Gulf Coast, also doing oil and gas, and you've got saltwater conditions. So there's a lot of things that factor into the devices. You have to ruggedize them. You have to make sure they're protected. The devices themselves, who owns them? Who has access to them, right? Is it yours? Is it the company you sold the piece of manufacturing to? Or is it, a third party that's monitoring it? Who owns the telemetry? And if they're going to allow you to access it, what will they allow you to do with it, right? And where will they allow you to share that information? The devices, it's almost impossible to see an organization that is standardized on a device. There's tons of different devices in the field. Each one of those uses a different set of protocols. They've got different firmware and different software, and keeping all of that straight is very much a challenge for an IoT deployment. Devices, there are a lot of them, or there can be a lot of them. So sheer volume and cost for these devices can be a barrier for some organizations as well. And then the final challenge with the device is, with some of these smart devices, we're finding that there's multiple parties that are responsible for that device. There's the primary manufacturer, but that manufacturer may OEM some components to a third party. So maybe the device does its monitoring, and it has its own proprietary monitoring software, but it passes off the networking protocol to a third party. So now you have to figure out, who do you talk to figure out how to make this protocol work? All right. So those are kind of some of the things that prevent companies from going all in with smart devices. And again, we're saying that you don't necessarily have to go all in with smart devices. You can still achieve that never fail service optimization without IoT devices. However, not turning you against IoT devices. They're awesome. They have a ton of benefit, and they will get you to that end goal faster. We're just saying, don't be discouraged if you're not there yet. You can still get to that never fail state. All right. With that, let's dive into the application and show you how all of this works. So again, I'm trying to provide hope here to the masses. I'm trying to show all that you can get to that never fail state without having an IoT device. And I'm kind of taking a bit of a roundabout way to show that. I'm actually going to show the process, the IoT process, first. We're going to walk through that, and then I'm going to strip away the IoT part and show you that same process, but in a manual state, right? So the end goal is that we're creating a work order for a technician to be dispatched and go and fix something. In neither case are we being proactive yet, because we're still in the data gathering phase. We don't know what the predictive failure state is yet. So we're just going through the data collection process of this. And I just want to show you how similar both of the processes are, whether you're connected or not connected. All right, so what we're looking at here is the actual, the field service, the connected field service application. What we're seeing here and what we're going to be showing is the concept of IoT alerts. Those are messages that we are getting from our Azure IoT central environment. And I wanted to kind of just talk about that just a little bit before we dive into the field service application. So this Azure IoT Central application is really a plug and play, turnkey solution ready for monitoring and tracking your IoT devices. I am using it in this particular environment I'm actually using the simulated devices that come within this IoT Central environment. In a production environment, obviously you're going to connect it up to your live devices, but here in this environment, I'm just using simulated devices. And what you're seeing on my screen here is the various measurements, the various telemetry that we're capturing from this piece of equipment. Anything from our gyroscopes and accelerometers to magnetometers, pressure, temperature, humidity, all these good kind of things. So the Azure IoT Central becomes the collector of all the info that's coming from all these different devices that are out there in the field. The key thing that it does then is it sifts through all those messages and it tries to apply rules to them. What we see here on the Properties tab, in addition to general information about the device, serial numbers, all that good kind of stuff, are down here with operational parameters. Now, these are really the thresholds that I can set on this device that say, anything beyond this, I think is going to be a problem, and I want to be notified of it. So for example, here, we've got a temperature alert threshold and a humidity alert threshold. We know that, for instance, or we suspect anyway, that if the temperature gets above 75 degrees centigrade, then bad things are going to happen. We also suspect that if the humidity gets above 99%, also bad things could happen with our components. So we've set up the system. These are our thresholds, and anytime that the system detects humidity, pressure, temperature that are above or out of bounds of our threshold, it will then send a message to our field service application as an IoT alert. So that's what we're seeing. That's what we're seeing here over on the field service side. So that's kind of what's going on in the background. Let's take a look at one of those IoT alerts looks like. So you can see, they keep coming in. I got one as little as 3 minutes ago, and that one was because of it looks like an elevated temp from a device. If I drill into that, I can now see, the device readings. So I can see, what's going on in real time. If anything's funky going on, I can see what the actual message was, as well as the device that it's connected to. On the top of my screen, I see my business process, so I know how to process this IoT alert in order to move it through to a closure. Right? Are we going to determine if this was really an issue, and do we need to send out a technician, or can we resolve it, or can we ignore it? One of the key characteristics or key value propositions of a connected field service environment is the ability to not send a technician to fix something. And how we do that is by, is trying to fix that issue remotely. And remote fixes are done by sending that device commands. We can define any number of commands inside the system, depending on the capabilities of the devices you're trying to talk to. So in some cases, we can ask the device for diagnostic information for help in troubleshooting. If it's a known issue, maybe we just want to send an automatic reset to the device so it can kind of hopefully fix itself. There's other commands that we can do to maybe update a firmware or update a software package, all things that we can do remotely. A key capability here is the ability to send commands from within the application. If you are sending commands and the device is not responding, you need to take the next action, right? We need to take this IoT alert and we need to turn that into a case. So from there, I can take the IoT alert, turn it into a case, and then save and close it, and boom, we're now at the case level. And same kind of thing. Maybe I pass it on to a teammate to do some further investigation. Maybe that teammate has additional commands they can send it to try to get it to respond or to get it to fix. Maybe I look through some knowledge base articles or error logs to find out what might be going on with this and attempt to fix it again remotely. If I'm not able to do that, again, I can turn this into a work order and actually get a service technician dispatched to go out there and fix this. All right. Nope. My work order type. There we go. So that is kind of the somewhat automated, somewhat manual process for taking an IoT alert that happened automatically and converting it into a work order, all the way trying to resolve it remotely without having to send a technician. The end result here is at some point we need to find out if there was a failure or if this was just an anomaly that can be ignored. Throughout the process here, I need to, as I close out either the IoT alert or the case or the work order, I need to be able to mark, was this a defect, was this a failure, or was this just an anomaly? And then use that information to collect, again, that intersection of that failure point with the date and time. How long has this component been in service? So that's the IoT flow. The application works the exact same way in a non-IoT or non-smart device environment. The only difference is the intake is not an automatic IoT alert coming from IoT Central. Instead, the intake in this case is a case record. So you're going to see an example here of my active cases, equipment not working. Right? That's typically what you're going to see in a reactive mode. The customer is going to call you up and say, piece of XYZ equipment is not working. Could you come please fix it for us? So they're going to open up a case manually by just creating a new case in the system. And then this simply, will be able to convert this case, excuse me, into a work order if they're not able to resolve it remotely. Same process, same output is, again, trying to correlate the intersection of a failure point and that point in time. So for this case, this is a manually entered case rather than one that was converted from an IOT alert. And I can simply convert this, to a work order. Again, if I'm not able to resolve this case remotely. So again, the processes are similar. The outcome is the same. It's just a little bit easier with connected field service device or connected field service environment to get to that never fail environment. It's all about prediction. Prediction's all about data. So hopefully this presentation has given you an idea of how data collection, regardless of whether it's automated or manual, is the key to getting you to that never fail environment. So Kelsey, with that, I will turn it back over to you.
Perfect. Thank you so much, Travis. That was great content and exciting to be able to see it actually in the application itself. So appreciate you taking the time to walk through that with us. And with that, I think we'll go ahead and end this webinar, and we appreciate everyone joining us for the presentation today.